Hey guys, so today's lesson is going to be all about absolute value equations. So if you recall absolute value, that's when we're talking about how far a number is from 0 on the number line. So basically, absolute value of 83 is going to be how far away from 0 is 83. That's going to be a positive 83. So basically, 83 is 83 spots away from 0 on the number line. Well, what about if our number inside the absolute value symbol is a negative? We also say that the absolute value of negative 83 is 83 because negative 83 is 83 spots away from 0 on the number line. So what we're noticing here is that the answer to both of these absolute value questions is positive 83. So the answer to absolute value is always going to be a positive number, no matter if the inside of absolute value is positive or if it happens to be negative. The answer is always going to be a positive number. Well, what about if we have multiple processes inside the absolute value symbols? That just means that we're going to work the inside of the absolute value using PEMDAS, order of operations, or actually GEMS, like we discussed in class before, because absolute value, the symbol, the two lines, those act as a grouping symbol. So we have to solve this the same way we would, if this was parentheses. So we're going to go ahead and multiply 2 times negative 8, and that's going to give us a negative 16. And then we're going to add the 5 to that. And so negative 16 plus 5 is going to give us a negative 11. And remember that all of that still stays within the absolute value symbol. And now we're going to say, well, what's the absolute value of negative 11? And remember, it's always going to be a positive number. It's 11 spots away from 0 on the number line. So the absolute value of negative 11 is positive 11. So the absolute value of any negative number is going to be that number's opposite. And the absolute value of any positive number is going to be that same number. So let's talk about the definition that we're going to use for absolute value. And the definition we're going to use is this. The absolute value of any number, x, is going to be x, that number, if x is greater than or equal to 0. Or it's going to be the opposite of x if x is less than 0. So going by that definition, the absolute value of this non-negative number, 6, it's a positive, is going to be a positive 6. However, if we have a negative number, like this negative 6, then the absolute value is going to be the opposite of negative 6, which is positive 6. Well, let's go ahead and consider this equation that says the absolute value of x equals 4. We actually don't know what x actually is, whether it's positive or whether it's negative. So that's going to lead us to 2 possible conclusions. The first possible conclusion we could draw from this is that, well, if x is greater than or equal to 0, then the absolute value of x equals 4 would imply, that would mean that x has to be 4. And the second conclusion we could draw is that, well, if x happens to be less than 0, then the absolute value of x equals 4 really would mean that x would be negative 4. Oh, excuse me. That x would be negative 4 inside the absolute value symbol, I should say. And it would help if I made this negative. There we go. So in drawing those two conclusions, what we're basically saying is that x could actually be two things. We could have two solutions here. X could be positive 4. X could also be negative 4. And in saying that, we can notate it this way, that x is positive or negative 4. So if we look at the position of the negative 4 and the 4 on a number line, we definitely, right there and right there. Oh, my circles are not looking too good. But definitely can see that, yes, they are 4 places away from 0 on the number line. Oops, my bad. 1, 2, 3, 4. And then from positive 4, 1, 2, 3, 4. So we saw that x could have been two different numbers. If it was in the absolute value symbol, that x could have been positive 4, x also could have been negative 4. But will the absolute value equation always have two solutions? Is it always going to be that x is either positive 4 or negative 4, or positive 100 or negative 100? The answer to that is a huge no. So let's consider this. If we look at this equation, the absolute value of x equals 0, we can actually see that this is the only value, 0, that's going to make the statement true, because 0 is the only number whose absolute value is 0. Now remember, 0 is neither positive nor negative. So if I were to plug in 0 for the x, it's the only number that's going to make that true. So x here can only be 0. That's not the only special case of absolute value. Something like this, where we have the absolute value of x equal to a negative number. As you can see here, I have it equal to negative 4. Well, in this case, the equation actually has no solution. Whoops, I can't even write right now. That's odd. I apologize. This actually has no solution because there is no number that has a negative absolute value. So this is going to bring us to our first actual example of the absolute value equations. How can we solve for x? How can we find out what x is? Well, the first thing we want to do is we want to go ahead and look inside the absolute value and see if there's anything that can be simplified, anything that can go together. Do I have anything that has the same last name? You know, any other x's that I can combine, or any other whole numbers that I can combine within the absolute value symbol. And I see that I have 2x and a positive 5. So in all actuality, that is as simplified as it's going to get inside the absolute value symbol. Now what I'm going to do is use the definition of absolute value to write two equations. The first equation is going to be that 2x plus 5 is equal to 11, or that 2x plus 5 is equal to negative 11. Because remember, our x can be two different things. It can be a positive or it can be a negative. So I'm going to write both equations without the absolute value symbols, and I'm going to make one a positive 11, the other one a negative 11. Now it actually looks like I have a disjunction, what we were talking about in the last lesson. So what I'm going to do is I'm going to solve each equation separately. So I'm going to look at my 2x plus 5 equals 11. And remember, I want to solve for x. I want to know what x could be here. So we undo the addition or subtraction first. So I'm going to subtract 5 from both sides, which is going to simplify to 2x equals 6. And you can see that we're not done yet. We don't have x alone. So what we're going to do is divide both sides by 2. The 2 is going to cancel out on the x side, leaving x alone. And 6 divided by 2 is 3. So we can see that x can be a positive 3. Or, now let's see what else x could be. So I'm going to perform the operations just like I did with the first equation, still subtracting 5 on both sides. But what's going to happen is when I subtract this time, because I'm subtracting from a negative 11, my 2x is going to be equal to negative 16. Remember, when we have two negatives, we add them together, keep the sign. We want to get x alone, so we're simply going to now divide both sides by 2. And I'm running out of room, but here we can see that x could be negative 8. So my two solutions to what x could be are x equals negative 3 or x equals negative 8. So let's go ahead and work on this one the same way that we did the last example. So we want to make sure that if there's anything in the absolute value that needs to get simplified, that we simplify that first, but I can see there's no way I can put that 3x with the negative 6 together, so we're simply going to move on to the next step. We're going to use the definition of absolute value to write two equations. The first equation is going to be 3x minus 6 equals 18. So it's going to look just like the original equation, just without the absolute value symbol. Or 3x minus 6 equals, and I'm running out of room, negative 18. Let's go ahead and solve the first equation that we have over here. So let's move that 6 over, and we're going to move it by addition. Whoops. All right. And that's going to leave us with 3x equals 18 plus 6. 24, if I can write the 4 properly. I'm struggling over here. There we go. And then we're going to get x completely alone by dividing both sides by 3. So x is going to be equal to 8. I apologize. I thought I had more room. All right, and now we're going to move on to the right side. Remember, this one is 3x minus 16 equals negative 18. Hold on. There we go. Negative 18. Well, that's not a good negative symbol. There we go. A little better. All right. And I can see that I made an error. This is supposed to be 6 and not 16. So my bad. Those of you that, caught that error early and corrected it, maybe you were waiting for me to see if I corrected it or not. Anyway, so it's 3x minus 6 equals negative 18. We're going to go ahead and add 6 to both sides. Now remember, we're adding 6 to a negative 18. So because they don't have the same sign, we're actually going to subtract 18 minus 6, and then we're going to keep the sign of the larger absolute value, which would be the negative 18. So we're going to keep it negative, and remember, we're going to subtract. So 18 minus 6 is going to give us that negative 12. Now we divide both sides by 3. Let's see how much space I have left. X is going to be negative 12 divided by 3. I have no space, but it's 4. Oh, I have a little bit of space. All right, awesome. Let's change colors here. Let's go with purple. All right, so remember, X is 8. forget that 3, or x can be 4. All right, so what I'm going to do is leave you with this very last problem, except this time I'm not going to do it for you. You're going to practice this one all on your own, and you're going to make sure that you bring this completed to class tomorrow. And when we come to class tomorrow, after we check this one, then we're going to have a little more practice and increase your knowledge of absolute value equations with some more challenging examples. Don't worry, it's going to be fine. All right, so I will see you tomorrow. Have a good night.